Hey everyone, it's time for another math lesson. So many teenagers know that the volume of a sphere is 4/3 pi r cubed, but very few know the reason why. Today I will prove to you that the volume of the sphere is 4/3 pi r cubed. I have drawn three lines in here in the colors yellow, blue, and red. The red one will resemble a hemisphere, which is basically half the sphere. And I'm going to have a cylinder with the same radius as it surrounding it, and the height of the hemisphere is also the same as the radius. So the volume of a cylinder is pi r squared times height. Now I'm going to take an inverted right circular cone and place it in the cylinder, and the volume of a cone is 1/3 pi r squared times height. So the base will be at the top of the cylinder and the point of the cone will be at the bottom. So to prove the volume of a sphere, I'm going to do something interesting. I'm going to cut the cylinder in, let's say, half, which I resemble here as H. Here. So this will be considered a height at which I cut the cylinder, which consists of a circular cylinder, sphere, and cone. Okay, so I'm going to call the radius Z. So the radius here and here are the same. So when I cut it, this is how the top view looks like. And when I look at the front view, this is how it looks like in a two-dimensional form. So in this 2D diagram, the letter H represents the height at which it is cut off. Z will represent all of the radius here. Y will represent the point at which it touches the semicircle. X will represent the point at which it touches the cone, which is the triangle. So here, the length Z and Z are the same, which makes this an isosceles triangle. Since X and H fall in the same shape, these triangles are similar, making this 9 degrees, and here will also be 9 degrees. So using Pythagoras theorem, Z squared is equal Y squared plus X squared. So if I add pi to this equation, pi z squared is equal pi y squared plus pi x squared. And pi y squared, which is what we want to find here since it touches the sphere, is equal pi z squared, which is the full cylinder, minus the whole cone. So for every cross section of diagram, so this thing can change, the formula actually remains the same. If you want, you can try it out. So the volume of a hemisphere is equal to the volume of a cylinder minus the volume of the right circular cone. So the volume of a hemisphere will be pi r squared times radius, because the radius in the previous diagram is the same. So it's actually pi r cubed minus 1/3 pi r cubed, which is equal to 2/3 pi r cubed. Since the volume of a sphere is twice of a volume of a hemisphere, the volume is 4/3 pi r cubed. Thus, we have proved that the volume of a sphere is 4/3 pi r cubed. Thanks for watching.